Okay, so the first CSRF level it's the one that just shows you the vulnerability and what happens when you don't do any protection against cross-site request forgery attacks. So that's what we have here. I've already instantiated the level. And so what this code lab is going to have you do is you bring up the level, and I've already brought it up. And the first thing for you to do is to look at how you access this site. And they give you a default login for this site, which is I'm going to log in. And you see that there's an update email button here. And the idea is to lure someone onto a site that automatically has them update their email. And in order to do that, we have to reverse engineer how the update email works. And so I'll do this inspect on this button. And if you look, this form, it's got an action that points to /myaccount/change email. The method is a post. It's got this email field that you see here. But it doesn't have a CSRF token. So you've seen in other levels that there is a CSRF token. And this allows anybody, if you are logged in, as I have just logged in, and I visit a site that has an embedded form submission to this PortSwigger site automatically put in, then I can do something like change the email automatically on a visitor. And that's what you'll be doing. Okay, so let me update my email address. And so I'll click update email, and you see my email has been updated. If you go into the network, you can see that the form submission is here. So this is the change email form submission. So it goes to my account /change email. And then you can see the form data. It only has one field, email, and it's got my Odin ID in it. So that is I guess that's you reverse engineering that form. And so all you need to do is trick the user into doing this form submission by having them visit a page that's got this embedded in it. And that's what we're gonna do next. The way we're gonna do this is through the exploit server. So again, with the exploit server, you can see you can craft any file at this endpoint. So when the victim is going to visit this this URL periodically, and then you control the file that's returned at that URL. And so in this case, the file that's there, the body of the file is just hello world. And so if you view the exploit, you see hello world there. And so what we're going to do is we're going to write a script that automatically uploads a particular form that will get automatically submitted when the user visits this exploit site. So that's the idea. The form that we're going to submit looks like this. So again, I'm going to visit this exploit server and upload so I need the link for the exploit server, which is what this does. So I basically will get into this site, get the URL of the exploit server. And then what I'm going to do is I'm going to put this embedded content on the exploit server for the victim to visit. And so the URL, we just reverse engineered the form post. So I'm going to rehost that form on my exploit site, and it's going to have that email field, but I'm going to pre-fill that field with some other email address. And then as part of this form, I'm going to embed a script on the site that will just automatically submit that form. And by doing so, this will automatically change the email to this person, so that when the victim visits this exploit site, it will automatically do the change email. And assuming that the victim is logged in to the site when they visit the exploit server. Okay, and then in order to submit this exploit HTML to the exploit server, this is just replaying this form upload that you see here. Like, and when you reverse engineer this form submission, you will see that the way to upload is to, in the response body, you would specify the HTML payload that you want to put in the body and then just store it. So let me run this. Well, I have to give the site. And so this site is here. So I'm going to run this thing. And then you can see this automatically solves a level. And oh no, you can't view the exploit because the exploit is gone now. Rats. Oh, you can see the access log though. So this is the victim. And you've probably seen this. Well, I don't know if you've seen this before, but like you can see, this is my IP address here at Portland State. So all of this stuff is Portland State stuff. But this is basically the, yeah, this is basically the victim accessing the vulnerability. Okay, so that's the base level. Let me go to the next one. Where am I? Okay, so the next one is basically the same. In fact, I should probably, I do, I've lost that page. Oops, wrong site. The next one is the same, except the token validation depends on the request method. So if your form submission takes both get and post, you need to protect, and you're only doing the protection based on one and not the other, then you could be subject to vulnerability. And so the second one is basically changing the post to a get. So I'm not gonna cover that one. It's basically the same script with like one change in it. So I'm gonna skip that. The next one is a token that's not tied to the user session. And so the vulnerability here is that anybody can visit a site and get a CSRF token. You need to make sure that CSRF token is bound to the actual user you issued it to, and that an adversary can't just get any old CSRF token and then trick the victim into using the adversary's token to do the access. And that's the second level. And so there are two accounts that you can actually use to validate that, in fact, the login, like a CSRF token that you get for this account, can be used to submit authenticated requests on this account. And this is, so I'm not going to walk through this because it does take some time to show you that this is possible. But basically, you would just copy and paste the CSRF token from one to another and then replay the request on the other account to show that this works. I'm going to show you the script that will solve it. So in this case, again, you have to get the exploit server's URL. You have to get the CSRF token, your own CSRF token. So in this case, you go to my account. I think you actually need to log in before doing this, though. Oh, but you know what? Any old CSRF token works. So you can just go to this account. It'll ask you to log in. And then as part of this, you get your own CSRF token. But you want to use this in the exploit server and get the victim to use it. And so before you use this CSRF token yourself, what you're going to do is you're going to take this value and then you're going to just embed it into the hidden form field of the exploit that you're going to host. And then the victim's going to use the CSRF token instead. And because the site didn't realize that it was you who retrieved it and the victim who is using it, then this will be allowed. So, and again, the same URI, the same email field, and then the same document submit. So that's what this thing is going to do. And Let me change the site. Shoot, I should have started this level before doing the explanation. Okay, so this is the site, and then this just is the programmatic solution for it. I don't know if this is worth waiting for, but oh well. I like getting the carrot. Even though I saw this level before, I still like seeing the carrot. And then you'll get that this this level is solved. Okay, so that is that one. The next one is the more involved one. And this is something that I'm going to take some time to explain. This particular one has this it has multiple vulnerabilities in it. So let me get to the code lab. I don't know why I keep navigating away from this. No, I didn't want that. Okay, so this this particular vulnerability is it's multiple vulnerabilities in one. The first vulnerability is what we call a header injection vulnerability. So what is that? So in your if you recall, in your cross-site scripting levels, one of the patterns that you had was that you reflected a search term onto the site, and then it is embedded in HTML content on the return. And by embedding script tags in that HTML content, you get code execution. Another way to reflect back into content that is returned from the server is to reflect it back into HTTP response headers. So if the web application sets like cookie values that might include adversarial input, then it is possible to basically inject HTTP response headers based on the stuff that you input in a form submission. And that's basically the first vulnerability here, is this header injection vulnerability. And then we're going to chain that with a cross-site scripting vulnerability that allows someone to set the CSRF token. So this is multiple things, and this is why we're covering it now and not earlier. The first thing I want to show you is the header injection vulnerability on this site. And so you'll see, just as before, if I inspect this page and I search for a term, and I go back into the network, and I click on the term, and I look at the headers that are coming back, you see that there is a set cookie where the search term is actually included in the response header coming back. So it's basically tracking what the last search term is, and then maybe this sets a cookie that allows you to set maybe something on the page later on. And maybe it uses that value to render that. So that's the idea. But the thing is these header fields are separated by new lines. And if you're just blindly echoing the input, this input back into the set cookie header, it is possible to inject a new line and generate a new header that gets echoed back and set on the response. And that's the vulnerability that we're going to look at first. So if you look at this script, this is a script to basically show that header injection is possible to set a malicious cookie. And that's what we're going to do. So this is a function that I'm going to use that takes a search term and then gets the search. So this is just the same as the URI for doing the search, which is up here on this URI bar. So that's what this is going to do. And then the headers that come back, so response.headers.items, I'm going to go through each one of these headers and print what the value is. And then I'm going to do that for this search term first. So let me run this. So I'm going to hit return, and whoa, of course, I did not actually set the site. Let me get this. Let me fix that. All right, now let me run it. Okay, so now I'm going to get the headers back from my request. And so this is sent as basically a dictionary gets sent back. So I just print out the whole thing. And you can see there is a dictionary for the set cookie, and it's got the last search term that is appropriate for what I just sent it. And so the next thing I'm going to do is get the header, try and inject a new line, and then insert a bogus header into the response. So the header foo and then the value bar is what I'm going to submit. And you can see that this is what I'm doing. So the search term has an injected new line, and I'm just going to search for that. And so you can see as part of the dictionary that comes back, you can see that the new line has been returned back, and a new header has been injected into the response. So what I can now do is I can inject another set cookie header. So you see this here. I can see if I can set an arbitrary cookie on this request. And we need this because we're gonna have to set the victim's cookie arbitrarily in their response as well. So that's what this thing is doing. Can I inject a cookie into this so that my cookies will have both the last search term as well as this bogus cookie associated with it? And so how do I get rid of start thread? No. All right. So you see the last search term is there, and the other cookie has been inserted into this into the cookie fields. Okay, so that's what I want to show you next. So one of the things that you'll see is that this last search term, actually, let me show you this in the script itself. No, actually, I'm going to show it to you on the page. What I'm going to do is I'm going to try and log into this page. And what you'll see when you go and get your account, if you look at the headers, the cookies will be there. The other thing that will be there on this page, if you inspect this page, is this CSRF token. So I'm going to log in using those credentials, and you see what the CSRF token is. It's WVK Y1J. So I'm going to log in, and I apologize for the last pass stuff. Actually, let me I forget to disable this all the time when I do these demos. Oh, shoot. Sorry. Sorry, I need this up before I do this. Okay, I'm going to do this again. All right, my account. I'm going to log in. Okay, so this is the network connection, and this is the login. And so what you'll see when I do the login and I do this post, you'll see in this set cookie, the session, the path, HTTP only, and whatnot. And then you'll see in the response, you'll see the CSRF token as well. When I go and I access this my account, you'll see the cookie has this CSRF token actually stored within it. And I think I must have in the response, or do I not have this? Yeah, I must have set the cookie earlier. But in the response, I have in the I have in the cookies. I'll go into the application and look at the cookies. I have in the cookies the CSRF token. Now, one of the ways that developers shortcut the handling of CSRF tokens is to store the token on the client and then have the client echo the token back into the cookie. And then if the CSRF token in the cookie matches the CSRF token in the form submission, then I call it good. And this obviates the need to store the CSRF token on the server. And the reason you would do this is to prevent a denial of service attack where you're issuing CSRF tokens and having to remember all of them. Well, that's one way to address that. So in this case, the CSRF token is being it's delivered back and set on the client. Now, what the script is going to do is show you that this is happening. And that's what this is about to do. It's going to visit the login page and then look at the results of the headers that come back. Okay, and I should show you this code. So this code basically goes into the login URL, parses out the CSRF token, and then also looks at the header fields to show you that as part of the headers, you'll have a set cookie that sets the CSRF token. And then you'll print out all of your cookies to show that the CSRF token is in them. And so this is the headers that come back. And you can see that the set cookie with that header is included. And then after you've logged in, you see that now you have a CSRF token. You have the CSRF cookie that you have set previously. Okay. I want to show you that this is being used to do all of the validation on the back end. So I'm going to show you what happens when I get the CSRF token, I log in, and I get the cookies. So this is basically getting the logging in and having that cookie sort of instantiated in my cookie store. And then what I'm going to do is I am going to post this thing. I'm going to get the login URL, and then I'm going to get my cookie set, and then I'm going to clear the cookies. And then I'm going to see, based on the CSRF token I got earlier, if I clear the cookies and then try and use that CSRF token, if all the server is doing is comparing these two things, the thing in the cookie and the thing in the login data, this should fail. And I'm going to show you this fails with this particular request. And so it says invalid CSRF token, even though I actually did get that CSRF token from the server. But because I cleared it out of the cookies, the comparison fails. Okay. So the next thing I want to do is show you that I could just set this CSRF token to be whatever I want it to be. And that's what the next set of in this program does. I'm just going to set it to my Odin ID and then set the cookie to the CSRF thing of the cookie to my Odin ID. I'm going to post this login using the login data here with the bogus CSRF token and the bogus cookie. And then I'm going to show you that I'm going to be able to successfully log in. So this is, yeah, CSRF token. So you get a status code of 200, and then the thing is successful. Okay, so this leads me to the exploit. You need to trick a user into setting the CSRF cookie and then using the cookie, or setting the CSRF cookie, and then using the CSRF token in that cookie to then change their email address. So that's the full-on vulnerability. And I'm going to walk through how this is done. And this is the payload. The first thing you want to do is you want to be able to, on the victim's browser, set the csrf cookie. And this can be done using the header injection attack. And this is why this thing is chained. And so if I search for this search term, so I search for my Odin ID, and then I set the cookie to a value like foo, then if I trick the victim into searching for this search term, the cookie will get established. So that's the first step of it. The next thing I want to do is submit a form that has this csrf token set to foo, and then will automatically, in this case, for this script, will automatically log in with the credentials. And so this is what this is an exploit that does this. So if I host this on the exploit server, it's going to create this form. And the form is to automatically log in using this username and this password. And so it doesn't even matter what the user is doing. Like the user could not, the user might not even know about this account. But because you're hosting it, they're going to log in as this user regardless if they visit this page. And you can see that I've hard-coded the csrf token to be exactly what the search term is. Now, when the user visits this page, they have to automatically be able to do this search. And that's what this is going to do. So I'm going to say image source, search for this URL, and this will create the cookie on the victim. And then what I'm going to do, because this thing is going to fail, on error, I want the submission of this form to occur. And the form submission is going to be done with this bogus cookie set. And the form submission has the csrf token also set appropriately. And then this should actually log in for me. So I'm going to upload this exploit, store it, and then I'm going to revisit this on the exploit server to show you that this actually works. So that's the next part of this exploit. Okay, so I'm going to view this on the exploit server. So you can see the image source is this, and it's got the set cookie. And then it does this automatic login. So if I view the exploit, as we were just talking about in the chat, you can see it redirects me automatically to be logged in as this particular account. So not only do I want to log in as this particular account, I actually just want, if the user's already logged in to this account, I actually want this user to update the email to point to me. Because again, if this is managing multi-factor authentication, then it would be nice for me to get that email changed. And that's what the actual exploit needs to do. And so all you'll do is just change this, you'll change the code for what you're going to submit just slightly. Rather than be a login, you're going to try and change the email, change it to anything. And then again, the header, the csrf value is foo. The search URL is the same because this is going to set the csrf cookie the same way. And then you're going to submit. And then this will actually solve the level when you store it, I believe. Or you might need to deliver it to the victim. I don't remember. And actually, it might not work at all because I've actually messed up the victim by doing this, by doing the other one. Yeah, this is actually not going to solve it because I think I forced. This doesn't work because I logged the user out of their account. I logged the victim out of their account by the previous exploit. And in order for you to solve the level, the victim actually with their logged in account has to get their email address changed. And because the victim, I basically have to wait for this to expire to get the carrot. But when you come across this in your lab, don't do the login form part. Just go directly into the change email part. Okay. Are there any questions about that for those of you who are still around? Okay, so let me get rid of that. It's duplicated in the cookie. I already did that. Okay, the next one is csrf with broken refer validation. So I'm going to start this up. That's the solution script. So one way to protect against CSRF attacks is to look at the referrer field on the request coming in. And if the referrer doesn't indicate that you're visiting from one of your own pages, then you would deny that request. This is kind of similar to same site cookies where you're trying to restrict access to just pages on your own site. But we saw earlier that the referrer header can be spoofed. And so that's the vulnerability here. In this case, we're going to try two logins. We're going to try and log in via a Python script. And the Python script is not going to have the referrer be the original site. So when you visit the original site, as we do here, typically when you log in from the traditional mechanism, what you're going to do when you do this request, you should see in the headers, the referrer is this URL, and the server, if you don't come from this URL to do this login, the server will deny your access. So I want to show you this programmatically. I am trying to, so I'm going to cut and paste the URI. I'm going to visit this site and then try and log in with no referrer, and you'll see that this thing fails. And then I actually need to set the referrer to this login URL, and then you'll see it will succeed. So that's the first thing I'll run. So I don't have the referrer set, so invalid referrer header. And then the second one, I do set it to the login page. And then basically I get a 200. So what I'm going to do is develop an exploit. So I'm going to show you a non-working exploit. So the first one, this is a similar exploit as we've seen earlier. What we're going to do is we're going to upload an HTML page that tries to change the email, and then do a document.forms.submit. So that's the first thing, and by doing so, the referrer header is not being set. So let me do that. And then what I'm going to do is I'm going to visit the exploit server and view the exploit to see what the victim is going to see. And so you can see this here. And then I will view the exploit. And you see invalid referrer header. So now we need to be able to trick the victim into setting the referrer header so that this thing will pass. And that's what the working exploit is going to do. And it's hard to just set in JavaScript. This is going to be executed in JavaScript. And so JavaScript does have ways of programmatically getting access to the headers. And in particular, one of the ways you can access it is through this history.push state, where you can then push onto the history of the JavaScript engine, the referrer URL, so that when the access happens, the referrer header will be set to the appropriate field. And so we're going to set it to what the server wants it to be, wants the referrer header to be, and then we're going to log in. So that's so this is the referrer URL for updating your email address. So that's what we're going to do, because when you do this update email, you can see in the network headers, the request header has a referrer field of my account. So that's why I am setting the referrer URL to my account. And then this is what's going to be included here so that the referrer is set appropriately on the exploit. So that's what I'm going to upload next. And of course, this solves the level. And it kills the exploit server, so I can't show you this, but that's how the level gets solved. Okay, questions about that, if anyone has any? I'm gonna close this out. I'll close that out. The last CSRF level is exploiting cross-site scripting to perform a CSRF attack to get the token and then submit the credentials. So let me start this lab up. Load up my REPL. Okay, so one of the things that you want to do is capture the CSRF token. And there are ways of capturing that if you have a cross-site scripting vulnerability. And so with full access to the JavaScript engine, you can actually go and ask for the CSRF token. And then on the response, parse the CSRF token and then submit the change email. So it's basically like what you're doing with your Python request programs. You can just basically do it all in JavaScript. And obviously, I don't want you to learn JavaScript. If you don't know JavaScript, I don't want you to have to learn it, which is why we're giving you the code for the JavaScript parts of this. But I do want to explain it just in case, because eventually you'll come across JavaScript somewhere. If you're in CS, you'll definitely come across JavaScript doing this, that, or the other. So I want to walk through the exploit and talk about how this script works. So what the script is going to do, it's going to both get the original page, get the My Account page, and then after it does, so it's going to send this request, and then it's going to register an event handler that says, when you have loaded this request, call handle response in order to process the request. And then in handle response, I basically get the return from the request, which is in this .response text. And I basically use the match function for JavaScript strings to find the match where you're looking for within the response the CSRF token. And that's what this is doing. You're looking for this pattern. And then so the slashes say this, the slashes denote the search that you want to do, the two slashes. And you're looking for a pattern that matches name equal CSRF, value is equal, and then a regular expression that says non-white space characters, any number of non-white space characters in a row. And then you'll see that when you do this, so if I go to my account on this thing, whoops, I need to go to my, oh, I have to log in first. So if I go to this page, you can see that this code pattern is here, right? So this is what it's trying to parse out using that regular expression. This particular, so between two quotes, double quotes, you are looking for non-white space characters and any number of them. I think that's what the \W. Actually, I don't know what the \W is, but I'm assuming that's what it is. Someone who knows regular expressions better can call me on it. And then what you're going to do is you're going to take the first match of that, or the first match of this regular expression, which will end up being this token that you matched against. Okay. Then what I'm going to do is I'm going to create another. So once I get this token, I'm going to create another request. And that request is actually going to do the post to change the email. Oh, any word character. Thanks, Brian. It's going to set this token in this post request and then change the email back. So that's the whole exploit. And then you're going to put this, we're going to post this into the comments. In this case, there's no exploit server because you can just upload this into the comment field of the blog. And then all of this stuff will happen, assuming that the user is logged into the same site. So this is posting a comment that you've seen before. So that's the entire script. It's basically just JavaScript, automatically doing JavaScript. So let me run this. Actually, oh, I need to set. Did I set the? I did not set the site. So then I'll run this. And then it will solve the level. There are some steps along the way that I have you show just for understanding of what's going on, I think, but that's more or less, that's the punchline of this particular level. All right, that actually does it for csrf attacks.